I'm Marc Wilson. I'm here today to begin a project in a machine shop at Jamestown Community College, which is located in the Olean, New York campus. A Haas CNC mill will be used to square up a rough block of wax. Before that can be done, the machine must first be set up and properly prepared. So let's go inside and get set up. This is the machine that will be used today. It's a basic 3-axis mill. It uses the three-dimensional mathematics system of Cartesian coordinates to plot and pinpoint geometric features to be milled or drilled on the part that is being manufactured. X, Y, and Z will represent the program tool position with respect to the part 0 point. I don't know specifically which model this machine is, but TM1 can be seen on the upper left of the machine. Now that the machine has been turned on, it will take a few moments for the control to boot up before we can proceed. The first thing that will be done is to push the reset button. This will clear all the alarms and turn on the servo motors. Next, all 3 axes will be home to initialize the machine. The zero return button will be pushed, followed by the all button. Normally, the power up restart button would serve the same purpose, but it's locked out on this control. The Z-axis can be seen homing as the quill slowly rises to its position at machine 0. There will be a hard limit switch at this location that refreshes its encoder to 0 as its grid position. Y is the shortest axis, running to and fro, and will not be noticed homing since it's already there. X is the longest axis, running right to left, and is now slowly homing to its extreme far left. Homing also helps to warm up the machine and lubricate the axis to prepare for operation. The first thing that must be done is to establish a part 0. The tool center line needs to be coordinated from machine 0 to this position as work coordinates. An edge finder installed in the tool arbor will be used to help find X and Y. Its diameter is 200 thousandths of an inch, meaning that the tool center line will physically be 100 thousandths of an inch from the tool's edge incrementally. Notice that the spindle can freely be turned by hand. Although the tool can still be inserted, it's more likely to shift out of position when the arbor is manually inserted. Manual data input will be selected, M19 will be entered into the control, and Alt will be pressed to overwrite the code word currently in the page and highlighted. This is a closer look at the single code word command that was just entered in the manual data input. Once the start button is pushed, the spindle will rotate to a fixed position where it can't be rotated by hand. The benefit of doing this is that the square notches of the arbor plug into the square plugs of the quill. If the spindle doesn't accidentally get turned slightly while inserting the arbor, its flange is less likely to catch on the plugs of the quill and break. This model of mill doesn't have a tool turret, so the tools must manually be inserted and changed by hand as needed. The manual data input and then the jog buttons must first be selected to allow this. Now the manual pulse generator will be used. Its resolution will be set to 100 thousandths of an inch and X will be selected. It's also known as the jog handle or the jog wheel. The table is manually being moved in X to position the vise underneath the quill where the work coordinates will be established and assigned to the G54 work fixture offset. Holding down the axis selection button, Z in this case, can also be used to achieve the same result. The spindle will now be manually started. 500 was just entered as the RPM. This is the lower left corner of the display monitor where the data was entered. The enter button will be pushed, followed by the clockwise button to turn the spindle on. The maximum velocity that the spindle will turn with the guard doors open is 500 RPM. If set to a higher speed, the spindle will automatically slow down to 500 if the doors are open. The fixed solid jaw of the vise will be the X-axis. The point where it intersects the Y-axis will be the Y0 point. Notice the wobble of the edge finder. As it slowly incremented against the vise jaw, there will be less wobble until it lines up straight with its own tool shank. Once at this position, the edge finder will be 100 thousandths of an inch away from its respective Y position. The resolution of the jog wheel was just set to 100 thousandths of an inch. This is the amount of axis movement that occurs for each click of the wheel as it's being used to fine-tune this setup. The edge finder is getting lined up straighter. At the point where it starts to kick back out, it was moved 100 thousandths of an inch too far. Looking at the edge finder from the perspective of negative Y, the kick out will be seen more noticeably. One click back will be the Y0 point. With the Work Offsets page selected and Y highlighted in the G54 line, the Part 0 Set button will be pushed to establish the tool's current center position as the Y0. Remember, the tool's current Y center position will be 100 thousandths of an inch away from the X-axis now that the Part 0 Set button has been pressed. It's currently at Y minus 100 thousandths of an inch, so 100 thousandths of an inch must be added to make the correction. These numbers reflect the work 0 coordinates with respect to machine 0. After the Part 0 Set button was pressed, the highlight automatically shifted to Z. It must be positioned back on Y as shown here before the Enter button is pressed to make the correction. Notice the change in Y after the Enter button was pushed. It now reflects the X-axis as the proper Y0 point. The X0 will also need to be established once the part is placed in the vise and its left side is edge found, but footage of this will not be necessary since you have just seen it in Y. The Z alpha character button will be pressed, followed by the G28 home button to retract the quill back to machine 0. A couple of parallels will be placed alongside the hard jaws of the vise to support the part and elevate it above the surface of the vise. After the part is inserted, a dead blow hammer will be used to seat the part. As the vise jaws engage the part, it's slightly lifted out of the vise. Unseen, the left hand will gradually tighten the vise while the part is being tapped. This will seat the part for a more consistent final milled thickness. A final check will be made with the left hand to be sure that the parallels are tight. All tools using a G54 work offset will share the same center line, so the XY zeroing process will not have to be redone for any tools using that offset. However, every tool will have different lengths. Each must be zeroed in Z to the top surface of the part. This 1-inch center cut end mill has 2 flutes and will be entered as tool number 1. After the tool is changed, a paper feeler will be used to help set the Z0 point. Although the tool is vertical, this is the horizontal tool length offset. The sheet of paper is 300 thousandths of an inch thick. When the paper begins to get pinched between the surface of the part and the end mill where it no longer drags freely, it will be at Z.003. The jog wheel is now being used to increment down 100 thousandths of an inch at a time. The end of the tool is concave, so it looks like more, but the cutting edges of the tool are now at this Z position. The tool offset page is active with the H length for tool number 1 selected. The tool offset measure button will establish the current position as Z0. 300 thousandths of an inch will have to be subtracted to reflect the proper Z0. Believe it or not, Notepad is a much easier to use text editor to write programs than doing so on the actual Haas control. They can be written on a personal computer and then transferred to the CNC control through a USB flash drive. As long as the programs are saved as text files with a .txt, .nc, or .pgm extension, and valid O program numbers as the file names, this will work. The programs being copied from the USB flash drive to the CNC memory are a master program and a can face milling cycle to mill the block down to its 1-inch thickness. After pressing the List Program button, the USB tab is highlighted as the arrow keys are used to navigate through the tabs and files until the desired file is highlighted. The F2 soft key will bring up a small prompt with memory highlighted. Pressing the Enter key will successfully copy the file. Paging back up to the USB tab and then navigating to the Memory tab will now show the listed file in memory. Although it can't be seen very well, a simulation was just run successfully. The F2 key and the page up, page down keys will be used to resize the focus area of the graphic simulation. The navigation keys will be used to reposition the area being focused. Each press of the F3 key will slow down the simulation by 10%, making it easier to follow the toolpath. A push of the start button shows a close-up of the two-dimensional wireframe simulation. The toolpath is being illustrated in terms of XY plane axis movement. The milling process will be featured in the next video. The machine is now set up and ready to begin a face milling process that will be featured in the next video. In addition, the sides of the block will be squared up. I'd like to thank the staff here at JCC for the use of this facility and for the knowledge that has been gained. I'm Marc Tex Wilson. Thanks for watching.